So today we are on page 338. Remember, we are still in the section where we're talking about cross-examination, where you have one solution, no solutions, or infinite solutions. So as I am working with this, I need to describe the graphs in a system of linear equation that has one solution. So if they have one solution, the graphs are going to cross. My handwriting is not very good right now. Okay. Describe the graphs in a system of linear equations that has no solution. Well, we just talked about these yesterday. These are your parallel lines. All right. So if we consider this system of equations, we're going to complete the table of values. So basically, I'm going to take each of these numbers and I'm going to plug it in for x in here. So if I do 3 times a negative 2, that would give me a negative 6 plus 6, which is 0. So if I do 0 times 3, that's 0 plus 6, which is 6. If I do 3 times 2, that would be 6 plus 6, which is 12. If I do 3 times 4, that's 12 plus 6, which is 18. If I do 3 times 8, that's going to be 24 plus 6, which is 30. And if I do 3 times 13, that's going to be 39 plus 6, which is then 45. And finally, 20 times 3, that would be 60 plus 6, which is 66. Okay? Then I have the other equation. So I'm going to still take those same x values and I'm going to plug it in here. Except this time I have a set of parentheses. Okay? So remember, the parentheses order of operations tells us we have to do that first. So a negative 2 plus 2 is 0. So 3 times 0 equals 0. So then I've got 0. So 3, that would just be 3 times 2, which is also then 6. Well, then I'm going to take, plug in 2. That's going to be 3 times 4, which will give me 12. And I'm going to plug in 4 this time, which is going to be 3 times 6, which is going to give me 18. And I'm going to plug in 8 this time, so that would be 10. So 3 times 10, that's going to be 30. I'm hoping you're seeing a pattern already. And I'm going to do 3 times, 15, which that's going to give me 45. And I'm going to do 20 plus 2, that's 22. So 3 times 22, that's going to give me 66. Okay, describe the equations that make up the system. What can you conclude about the number of solutions to this type of linear equation? Well, if I plug in 2 and I get the same answer both times, that's the same. If I plug in 0 and I get the same answer both times, that's the same. If I plug in 2 and I get the same answer, if I plug in 4 and I get the same answer, how many answers are going to be the same? You're going to have all of the answers are going to be the same. Well, I now have these two equations. Let's see. It says both of these people went ahead and solved them. So we have Arav, and Victoria. So Arav went ahead and did what we call distributing. So they said, okay, well, I've got 3 plus 6, and then I end up with the other side, 3 plus 6. And they subtracted 3 from both sides. Now remember, that cancels. Does 6 equal 6? Well, it sure does. So that's a true statement. Okay, well, in this side, let's see, what did they do here? Well, it looks like they distributed as well. So if they distribute it, and so then they end up with the same thing, but instead they subtracted 6. So the 6's cancel, and I get 3x equals 3x, and I divide by 3, and that gives me 1x equals 1x. Well, is that true? It sure is. So I have both of these saying that they're true. Explain why they're correct but they have different solutions. So they both cancel out something. One has a variable and one is the constant. And the reason they're both okay, the reason they're both correct is because the equations are the same on both sides. So the equations are the same on both sides. Okay, so how would you interpret the final equation in your solution? Well, is it 6 or is it x? If it's always the same, then it's actually going to be what we call infinite solutions. Okay? It's always true because it's always the same. So it's going to be an infinite number of solutions because I could have 4 and 4 are the same, 5 and 5 are the same, 6 and 6. And I could go as high as I wanted to. All right, please turn to page 340. Now, what we're going to do is we're going to do the same thing, but this time we're going to solve it algebraically. So let's use what we've learned. So Samson and Adrian helped set up booths at the fair. The organizers pay them each $7 per hour to carry the wood. Well, Samson arrived at 7 a.m. and begins working immediately. Adrian arrives 90 minutes later and then starts working. Okay, so the first thing that they want me to do is to write my equations. Well, I've got y equals 7x, right? He shows up at 7 o'clock, starts working. 90 minutes later, how can I do that in hours and a half? 90 minutes, how long is that? Well, I know it's 1.5 hours, right? So this is going to be Samson's equation. So then Adrian's equation is going to be y equals, he's still getting paid $7 an hour, but he is an hour and a half less time than Samson. So I'm writing that as a something I'm going to have to distribute. So what I can realize is I need to distribute first. So if I'm going to distribute this, so then I get y equals 7x. And then when I distribute that, that's going to be minus 10.5. Okay. Now, here are my equations. Y equals 7x and y equals 7x minus 10.5. Well, what do I notice about this number right here? That slope? Slope is the same. So I know that the lines are going to be parallel, or they also could be the same line. So we know that this one is actually y equals 7x minus 10.5. Okay, so we're going to solve it algebraically. So I'm going to take this part and set them equal. So I'm going to do 7x equals 7x minus 10.5. Now to solve it, I subtract my 7x from both sides. That cancels and that cancels. I'm left with 0 equals a negative 10.5. Is that true? Does 0 equal negative 10.5? That is not true. So this would be not true. Okay? And since that is the case, I'm actually going to say that that has no solution. There is not going to be a single place where those are going to cross. Okay? It says, what is the result when algebraically you have parallel lines? So it would be like 0 equals negative 10.5. That's not true. Okay, I'm on to page 341. On Monday night, the fair runs a special for the local schools. When you purchase tickets from the school, you can buy student tickets for $4 and adult tickets for $4. You buy 5 tickets, spend $20. Write a system of equations. Okay, this one is a little bit more difficult. I'm going to give you, well, the first one we can talk about. So I've got $4 for the student tickets. I've got $4 for the adult tickets. And I spent a total of $20 because I have dollars, dollars, dollars. I know that I bought 5 tickets. So this is actually going to be S plus A equals 5. Okay. Now, what they want me to do is how do I solve it? Well, I've got to plug something in. Okay. So what I'm going to do is I'm going to take this equation and I'm going to get the A by itself. So what I'm going to do is I'm going to subtract the S and subtract the S. So I'm going to get A equals 5 minus S. I know we really haven't done this a whole lot, but this is going to be plugged in then for the A. Okay, so now that that's there, what do we know about the solution by looking at the equations? They're going to cross. Okay, so now I have 4S plus 4A equals 20. And we said this one was going to be y equals 5 minus x. Okay, I just had a's and s's instead. Okay. So what they have here, oh, they went ahead and changed those for me. So that they have the y equals. Maybe we should just use these. So if I have y, I'm going to set this equal to each other. So negative x plus 5 is equal to negative x plus 5. Well, if I add my x over, I'm going to see that those cancel. Oh, so maybe they're not going to cross. Does 5 equal 5? Yes. Does it make sense? Yes. So if I go back, I'm actually going to have to look back at this. They are not going to cross because they are actually the same line. So they'll cross an infinite amount of times. So if I've got my graph, right, and I've got start at 5, go down 1 over 1. Well, my next line starts at 5, goes down 1 over 1. It's the exact same line. All those little spots on the line that they cross is all the same. Okay, here's what you're going to do. You are going to now do a booklet with a partner. Okay, this is going to be posted in Google Classroom. Once you have completed the booklet, you are then going to work on a worksheet for homework. This will be homework lab if you do not have it completed by tomorrow. Take your time.